Bismillahirrahmanirrahim. We have a little bit discussed the microflora, microfauna, their types which are present in the soil. Now, is there any importance of these microbes? So, in this case, we would be discussing the importance of the soil organisms as a whole. And these importance, they could have two types: beneficial effects, harmful effect, or injurious effect. So thinking that the first category in this lecture, it is the beneficial effect, helpful effect, that they provide some benefit to the soil or indirectly to the human being community. So the first and the most important impact of these microbes is the decomposition of the organic matter. The most important role is the decay of the organic matter. Some 90% of the decay is because of the microbes. All biogeochemical cycles, nutrient cycling, depend upon a specific set of microbes. For every biogeochemical cycles, the microbes are different. Termites decompose cellulose residue. Soil from termite mound is more fertile due to high organic contents, nutrient availability, and improved soil structure. So aggregation occurs, nutrients are available from the termites mounds, and these mounds, remember, they are within the soil in a deeper layers. Actinomycetes decompose cellulose chitons. This is another impact of small organism, micro flora, fungus have actinomycetes. They can decompose, they can cause decay of the cellulosic material and chitinous material. Some nematodes feeding on organic matter assist other decay organisms. Nematodes, they feed on the organic matter, and then whatever is excreted, that becomes susceptible to the decay organisms. Soil arthropods shred, chop, cause fragmentation of the organic material of the litter into smaller pieces that facilitates decay organisms. Earthworm ingest organic matter. They are important in the upper 15 to 35 cm layer, or say simply, if you don't remember cm, say in the upper surface layer. The weight of material passing through their bodies as a cast each day may equal to the weight of the earthworm. इसका मतलब ये है कि अर्थवर्म का जितना वेट है अपना, उतना मटेरियल ये पास करता है बॉडी में से एज ए कास्ट, और दैट कास्ट देन is in the form of humic substances. More nutritious nutrients are there. Earthworms also can feed reportedly on cow dung. This is again a decomposition material and process. They may excrete 10 to 15 tons of casting per year per acre. 10 से 15 टन तक कास्टिंग. अगर आपने कभी जहाँ पे ये अर्थवर्म्स हों तो आप देखें कि छोटे छोटे दाने बने होते हैं गोल गोल से, ये कास्टिंग कहलाती है महीन से. तो ये एक साल में एक एकड़ में 10 से 15 टन मटेरियल एक्सक्रीट होते हैं. दे यूटिलाइज इट, एक्सक्रीट इट. इन ट्रॉपिक्स some 250 megagram castings per hectare per year, that equals to 110 tons per acre per year may be produced. Earthworms castings have high bacteria. अब क्या फ़ायदा है इसमें, इनकी जो कास्टिंग्स है, सिक्रीशंस है, कास्टिंग मीन्स वो जो एक्सक्रीट करते हैं, इसमें बैक्टीरिया हाई होता है, ऑर्गेनिक कंटेंट्स हाई होते हैं, अवेलेबल फॉर्म में NPK हाई होते हैं जो कि न्यूट्रिएंट्स को अवेलेबल होते हैं. सो दैट इज़ दी magic. Incarnates pass large quantities of plant and minerals material through their guts and help like earthworms in humus formation. Second रोल जो ये प्ले करते हैं inorganic transformations हैं. Organically bound compounds are converted into plant available forms by various microbes. The availability of iron, manganese is also due to the microbial action, especially in well-drained soils. Well-drained means where water would not stir, that has moisture, but the moisture is drained and irrigation is there. Some bacteria produces phosphatase enzyme for phosphate hydrolysis. Nitrosomonas, thiobacillus, they can mobilize inorganic phosphate by producing nitric and sulfuric acids. Species of thiobacillus or ferrooxidans, thiobacillus specifically ferrooxidans, bacillus pseudomonas, proteus, ecalogens cause iron transformation into soil. So iron material अगर है ferric से ferric to ferrous. Bacillus pseudomonas arthrobacter species can catalyze oxidation of manganese. Nitrogen fixation. Atmosphere has 79 or 78% nitrogen in inert form, which is not available to the higher plants elemental form में. लेकिन और ये पौधे cannot use it. However, it is converted to available state by some microbes. कुछ microbe जो कि हमें harmful नज़र आते हैं, गंदे नज़र आते हैं, they can transfer this unavailable form into available form और मुख्तलिफ तरीक़ों से. Non-symbiotic fixation by blue-green algae may be blue-green algae cyanophyceae के जो member हैं, nostoc वगैरह, Oscillatoria, nostoc, revoluria, they can fix up to 100 से लेके 150 kilogram of nitrate per hectare per year under favorable conditions. Favorable conditions, soil conditions में, temperature conditions में. ब्लू ग्रीन एल्जी जैसे कि नॉस्टॉक है, रेवलूरिया है, एनाबीना है, ऑसिलिटोरिया है, फॉर्मीडियम है, all of them they can convert atmospheric nitrogen, elemental nitrogen, N2 into NO3, which is the available form and available to the plants and to the other organism. Bacteria like Azospirillum, Azotobacter, Clostridium, Bygerankia, and Streptomyces, Frankia, Bacillus, Klebsiella can also fix up nitrogen. That is, their rate could be 30 gram of nitrate per hectare. So they can also do it. Symbiotic fixation can be done by Anthoceros, जो कि ब्रायोफाइट है, एजोला है जो कि टेरिडोफाइट है, साइकेड्स है जो कि जिम्नोस्पर्म्स है, गुनेरिया है जो कि एंजियोस्पर्म है, और ये सारी इनके साथ एसोसिएटेड सिम्बायोट जो है वो नास्टॉक या नबीना है और कभी कभी ग्रीन एल्जी भी हो सकती है, बट मोस्टली दीज आर द ब्लू ग्रीन हु कैन फिक्स. अगर अजोला आपने देखा हो, छोटा सा पौधा है तिकोने टाइप का, initially it is green but in winter it becomes reddish color. Lichen association जो है of nostoc with the fungus is an obligate association. Nostoc provides nitrogen. Nostoc symbiotically in association provides nitrogen from the air and converts it into nitrate. Fungus provides living conditions to algae habitat. ये obligate relationship I am saying, obligate associate, ये एक दूसरे के बगैर जिंदा नहीं रह सकते. They cannot live in isolated form. They have to be in a combined form. ये compound plant कहलाता है. Azolla and Abina symbiotic association can add nitrogen up to the tune of 240 kilogram per year per hectare. एजोला एनाबीना, एजोला के अंदर एनाबीना होता है. एजोला इज अ फर्न ट्रेडोफाइट, एनाबीना ब्लू ग्रीन एल्जी है. पैडी फील्ड्स में इसको कल्चर करते हैं, प्रोवाइड करते हैं, और ये नाइट्रेट्स की जो रिक्वायरमेंट है इट इज़ फैसिलिटेटेड. फॉर दिस पर्पज़ चाइना में स्पेशली और बहुत से अदर कंट्रीज़ में एजोला सेंटर्स हैव बीन एस्टेब्लिश्ड टू कैप्चर एटमॉस्फेरिक नाइट्रोजन. लिग्यूम राइजोबियम सिम्बियोसिस एक और एसोसिएशन है. लिग्यूम, अगर आपने लिग्यूम कहते हैं फलीदार फसलों को, लिग्यूमिनोसी के मेंबर, पी, मटर, इनमें रूट नोड्यूल्स होती हैं. ये रूट नोड्यूल्स दे कंटेन आइदर बैक्टीरिया, ब्रेडीराइजोबियम or azorhizobium, or they may contain other bacterial species which fix nitrogen. That is, they convert atmospheric nitrogen into with the help of the rhizobia or rhizobium. I gave you these two names, bradyrhizobium, azorhizobium. They convert into nitrate. Some 17,000 species of legume they can fix. Green manuring by leguminous plant is also a source of nitrogen. Green manuring. Green manuring का ये है कि मतलब कि if you cultivate this fodder, clover, which is a legume, तो अगर आप इसको हल चला के ज़मीन में ही छोड़ दें तो दिस नोन एज ए ग्रीन मैन्योरिंग. इसके रूट नोड्यूल्स में नाइट्रोजन होगा और प्लांट्स में भी नाइट्रोजन, लीव्स में भी नाइट्रोजन, एंड दे गिव यू फर्टिलाइजर्स. और अक्सर दिस वुड बी इक्वलेंट टू 40 to 100 kg of nitrogen fertilizer per hectare. Up your application of the nitrogen that would be reduced, commercial fertilizer would be reduced, cost of cultivation would be reduced by just green manuring. Some non-leguminous plants भी capable हैं, जनरली तो leguminous है, लेकिन नॉन leguminous plants like एलनस है, मिरिका है, कैजोराइना है, कोएरेरिया है, एलियग्नस है, ट्रिबुलस है, they can also fix free atmospheric nitrogen in association with actinomycetes के जो member हैं. Role of bacteria in nitrogen cycling is very much prominent. Nitrogen cycle cannot be run without Nitrosomonas, Nitrobacter, Nitrospira, Nitrosolobus or Nitrosococcus, because they fix up, they convert unavailable nitrogen into available form. Available form, remember, it is the nitrate. But at the same time, some of the bacteria, like species of Pseudomonas, Azospirillum, Rhizobium, Propianobacterium, Acaligenes, they can cause the reverse, denitrification. If a soil has a nitrate, and if these bacteria are present, they can denitrify, they can change them into ammonical form, gaseous form, and they would evaporate from the soil, would not be available to the plant. So both processes occur. Another role which is played by them is the PGR, plant growth regulating substances, या release of growth stimulating substances. Some heterotrophic bacteria and higher fungi produce 3-indole acetic acid and other growth promoting substances which promote root growth, shoot growth, and the plant as a whole. Gibberella fujicoria, this is a fungus which produces gibberellin. Gibberellin is used commercially for promoting the growth of the plants. This is extracted or produced by Gibberella, which is a fungus, bacteria. Now this is another technology, seed bacterization, that you coat the seeds with bacteria This coating of the seed with certain specific bacteria, rhizobacteria especially, is known as seed bacterization. This is emerging biotechnology that enhances the productivity of crops by effectively protecting seeds against diseases. Rhizobacteria produces growth regulators, enhances root exudation, promotes root branching, promotes growth of plants, rhizospheric functions और increases plant yield. तो अगर आप सीड बैक्टराइजेशन करते हैं disease के against, that seed would be properly retained in the soil, and it would also produce the regulators, growth regulators, which can cause prompt germination, prompt radical growth, prompt branching, increasing the overall growth of the plant. Such bacteria applied to seeds or roots colonize the roots and stimulate plant growth. Species of Bacillus, Azotobacter, Pseudomonas, Azospirillum possess such growth promoting activities and capabilities. Some fluorescent pseudomonads also stimulate plant growth. Now there is another physical feature, that is improvement of soil aggregates, segregation of soil particles. Fine particles, they make clay soil, which is not very good soil. Coarse particles, which makes very porous situation, which is also not a good soil condition. Soil aggregation, that is certain microbes, arthropods, algae, fungi, they cause improvement of the physical, chemical, biological activities of soil by aggregating particles. Smaller particles, they are aggregated into combined particles by bacteria, blue-green algae, slime molds, mollusks, all of them. And that aggregated soil behaves like a coarse particle, although it consists of fine particles. So smaller particles, they get aggregate with the coarse particles, or fine particles, they get aggregation with the among themselves to make larger particles. Soil mixing is another feature, which is a good feature. Micro, macro burrowing animals mechanically mix the huge amount of soil and bring it to the top. You might have seen wherever there are holes, even ants के जहाँ पे हैं मैगी, उसके बिल के साथ जो सुराख है, मिट्टी इज देयर, या कोई भी आप बर्रोइंग एनिमल्स है तो वो सॉइल को बार बार फेंकेगा और दूर से आपको नज़र आ जाएगा जी कि यहाँ पे सुराख है, क्योंकि soil would be lying outside. So they bring about, mechanically mix huge amount of soil and bring it to the surface. They also take material, the food material, grasses, food, seeds into the holes. So both way activity is there. Earthworm activities are at the peak, top peak पे spring और autumn में होती है. In a very low temperature, in a very high temperature, they cannot perform well. Suitable temperature में they definitely can give you 25 tons per hectare per year of the material, costing material in the top 15 to 35 cm of the soil. The weight of the material passing through alimentary canal of earthworms per day, daily, is equivalent to the weight of the earthworm. In tropics, 250 megagram per hectare per year costs are produced. Gophers, burrowing animal है, bring approximately 25 kg per hectare per year of the subsoil to the surface. Such animals cut and bury vegetation for food and nesting, which along with their excreta, they improve the soil within those caves or burrows. टर्माइट्स पे आ जाते हैं, वह नो हर चाहता मालूम दी, इवन ज़मींदार नोज कि वह न फसल ख़राब हुई, गनी ख़राब हुई, ज्वार ख़राब हुई, ऊने जुड़ो ख़राब हुई, पुटी उचीगी कुरुनो के they make up holes, tracks, wood, they are always causing a negative, but still they have a mixing of the soil of the plant material. They have mounds within the soil, maybe up to 6 meter or more high within the soil, deeper. Each mound or each may have a colony of 1 million or more termites or termite individuals. These mounds are abundant after 10 to 20 years. 10-20 साल के बाद उनका जी उगता जाता है, छोड़ देते हैं, किसी और जगह चले जाते हैं. These soils have these mounds, they are good aggregate structure and nutrient status. Soil organism by burrowing improve soil aeration. This is not a secret factor. Everyone knows small or large channels, burrows, living places, they facilitate gaseous exchange. Roots penetrating into the soil leave channels passage after their death and decay and improve. Let me give you a very common example. Nowadays, हमारे जो घर है, छतें हैं, ये तो पक्की होती हैं. पहले ज़माने में छतें लकड़ियों की और इन चीज़ों से बनती थी, एंड इट यूज टू बी mud soil covered. Wherever a grass grows there, the people know that bute mulshi jule pati shibya deke da kota sasi. That is the role. Roots during their lifetime, they make burrows, penetrate into the soil. When they die, after death, that channels, small channels, they remain there. They are helpful in the improvement of aeration. They are helpful in the movement of the microbes. They are helpful in the movement of the percolating water. Nutrient cycling. These are again a role of the biogeochemical cycle. Nitrobacter, azotobacter, nitrosomonas, they play important role in nutrients like N, P, S, F, M, and K calcium cycles. Every nutrient has its own cycle, and for every cycle you have their own bacteria or microbes. Sulfur oxidizing bacteria like species of Bacillus, Bagiota, Thiobacillus, Thiomicrospora, Sulforobus, Sulfuromonas, Pseudomonas, they run sulfur cycle. So nutrient cycling is also because of them. Soil binding, as in the previous talk we said, they cause soil aggregation. They bind soil. Algae, blue-green algae growing on a soil make the soil slippery because of the slimy release excretion, and that soil is tough soil. Similarly, some bacteria secrete sticky soils. Arthropods release slimy substances, slime bacteria. Arthropods also release these. So snail slugs, they also provide slimy substances, so they bind the soil. Binding soil would mean they reduce the erosion. Bioremediation, some of the organisms belonging to bacteria or algal group clean up the soil and water bodies by filtering and degrading toxic substances, including heavy metals, herbicides, petroleum spills, and other pollutants. So they can uptake. They can uptake bacteria, algae, other microbes. They can utilize these polluted materials into their body and would transfer them to another place. So bioremediation is there. Antifungal activities of bacteria. Some of the bacteria uh, organism, they have interaction, positive, negative. Antifungal means all those organisms which have antifungal agents or which can produce antifungal chemicals, they perform this. Pseudomonas, fluorescens, and species of xanthomonas produce antifungal chemicals against the pathogenic organisms. They inhibit spore germination. They inhibit mycelial growth, thereby promoting the growth of the desired plant. Some actinomycetes produce commercial antibiotics like streptomyces, tetracycline, chlorophenicol. All of them, their antibiotic substances are there. Chopping fragmentation, this is the role of the larger macro animals, arthropods, or rats, mouse, ऐसे जो हैं, they can cause breakdown, although they may not play, but they make the ground more conducive for the microbial action. Thank you very much for listening.